Good afternoon. I'm going to go over the proportionality quiz. Number 1, the table below shows the cost for various pounds of coffee at the coffee shop. What is the cost in dollars per pound of coffee at the coffee shop? Well, how we work this out, we're trying to teach the kids that this is Y, which is the cost, and this is X, the coffee, or pounds. Money is always Y. And so we're looking for the change of Y over the change of X. How does it change? Well, if I do cost of dollars and I go from $2.40 to $4, that's a $1.60 difference. And if I go from $4 to $5.60, that's a $1.60 difference. Well, 1.5 to 2.5 pounds is 1, and 2.5 to 3.5 is 1. So the change in Y over the change in X. So my answer would be $1.60. Number 2 says, what is the rate of change for the data in the table shown? Well, the rate of change is the change of Y over the change of X. So how much did the Y change from the 2 to the 4, the 6 to the 10, and the 10 to the 14? It changed by 4 each time. And then on the X side, how much did it change from the 1 to the 3, to the 3 to the 5, to the 5 to the 7? It changed by 2 each time. And so what we have is the change of Y over the change of X, or 2 is the rate of change. Number 3 says, Tiffany and Xavier go to the store to buy drinks. They only have $11 to spend on drinks. The table below shows the proportional relationship between the total cost that they will pay before taxes, depending on the total number of drinks purchased. All right, so what does a constant rate of change represent in this situation? Again, we're dealing with the change of Y over the change of X. How much did I change from each one? Well, this side I changed $2.50 every time. So that's my change of Y. And then over here I changed 2 every time, and that's my change of X. But if I take $2.50 over 2 and I reduce it, I get $1.25 over 1. So it says for every drink they purchase, they will spend 80 cents. That is incorrect. For every drink they purchase, they will spend $1.25. I would choose B. This says $2.50 and this says $10. So those are both incorrect. Number 4, Joe and Mary's speed are recorded below. So Joe's speed is going 10 to 1, 10 to 1, 10 to 1, 10 to 1. So Joe's change of Y over change of X is equal to 10 to 1. Mary is going 8, 8, 8, 8, 8, 8, and 1, 1, 1, 1, 1, 1. Alright, so I get time is always X, and distance is Y. So I have the change of Y over the change of X, which equals to 8 over 1. So I have Joe's speed going 10 to 1 and Mary's speed going 8 to 1. So if I graph Mary's speed, then I would basically have a line just a little bit less than Joe. And because of that, it says Mary's average speed was 2 meters per second faster. Well, Mary is not faster than Joe, because it's taken Mary, right, after 1 second, she's only gone 8. She's only gone 8, right? Well, Joe's gone 10, so he's definitely moving faster. So Joe's average speed was 10 meters per second slower than Mary's. Well, no, he's not slower. Mary's speed was 8 meters per second slower than Joe's. She was definitely slower, but the speed was 8 minus 10, which is equal to 2. So that is incorrect. Joe's average speed was 2 meters per second faster than Mary's. I would agree with that. So we're going to pick D. Number 5, the graph shows the number of words in Taylor's essay and the number of minutes she spent writing the essay. What is the rate of change in words per minute? Right? And so the rate of change is the change of y over the change of x. Right? And so if you look here, change of y is 50 and over is 2. So I would have 50 over 2, which is equal to 25 over 1. Graphing this, I would just graph the 2 and the 5 like that, and put a 2 and a 5 in front of the decimal. Now, it says in words, right? So I'm going to say that I do 25 words, right, per minute. 25 words per minute. Number 6 says record your answer and fill in the bubbles on your answer document, right? Determine the constant of proportionality. Right, so we're trying to find, I wonder what? Oh, wait, the change of y over the change of x. So here, I'm changing 130 every time. And here, I'm changing 2. Right, and so if I do 130 over 2 and reduce that, I get 65 over 1. So my answer would be 65. And I would put it in front of the decimal. Number 7, same concept, change of y over the change of x, right? And then if you look, we went to the 15 and over 1. So I went 15 and over 1. So I would put the 15 in front of the decimal and bubble in 1 and the 5. Number 8, Arnold, Laurie, Chester, and Kayla each grew a plant from a seed. They measured and recorded the heights of their plants in centimeters as shown below. Right? They want to know which plant grew proportionally over time. Proportionally means, right, that they have a change of x and a change of y that is constant. Right, and it goes through the origin, which is 0. So if you look, they all go through 0. Right, and they start off, every one of them goes 4 days. Okay, so if we look, days or time is always x. So we're going to get a 4 for the x, the change of x. Now if you look at Arnold went from 0 to 1, so that's 1, and then 1 to 2, that's 1. But then he went from 2 to 5. Same amount of days, 4 days, but he had a change of 3, so I would say no to Arnold. Lori went from 0 to 3, 3 to 9 to 6, and then 9 to 18. Well, she is not steady. It should be 3, 3, 3, or 6, 6, 6, or 9, 9, 9, so no. Chester went from 0 to 3, 3 to 6, and 6 to 9. I would agree with Chester. And the constant of proportionality is 3 over 4. Number 9, the graph shows the time it took a worker to package 16 bottles of shampoo. What is the rate of change? What is the change of y over the change of x? Well, the rate of change, if I go up, the rate is the rise over the run. So the rise over the run. How much did I rise up? And how much did I run over? Right, so I would say that this is 2 fifths, or 0.4. Number 10, which of these does not represent a distance, the distance a car travels when going 55 miles per hour? Well, right here, this pretty much tells me I'm going 55 miles per time, which is t. So per hour, I'm going 55 miles an hour. So I would say that it does represent. They want to know which one doesn't. Right? Well, this one went from 55, right, to 82.5, which is 27.5, and 27.5. But I only went up a half and a half, right, or 0.5, 0.5. Well, as I go up, if you look, I went from the 1 to the 2, which is 1, a total of 1. And in here, I went from 55 to 110 for a total of 55 miles per hour. So I would say that is a true statement as well. C, you really got to pay attention to C because it's going through the origin, but it's not crossing the 1 until it gets about right there. So it's just a little bit above the 50, which tells me it's probably close to 55. So that is a true statement. But over here, if I take 3 and multiply it times 55, which is time times miles, then I get 5 and 1 and 15, 16, 165, not 160. So D would be my answer. Number 11 is our final problem. Right, we're going to graph the tortoise in a table, graph the hare in a table, graph them on a graph, and then tell the rate of change for each and which animal is faster. So the tortoise can walk a half a mile in a quarter of an hour. So they can walk 1 mile in a half an hour. And they can walk 1.5 miles in 3/4 of an hour. And they can walk 2 miles in 1 hour. The hare can walk 1.5 miles in a half an hour. So he can walk 3 and 1, 4 and 1/2, and 1 and 1/2, and 6 and 2. So when I go over here to graph this, I'm going to graph the tortoise first. So if I go half a mile, which is about right here, and a quarter over, so half a mile up, quarter over, I'm going to put a mark. So I'm going to do that every time. So half a mile, mark, half a mile, mark, half a mile, mark, until I get 2 to 1. And so if I graph that, I have a line that looks like that. I'm going to switch and use the red for the hare and green for the tortoise. So we're going to name this the T. Right, so I'm going to do 1.5 to 3. 1.5 to half. So I'm going to go up 1.5 to half, right? I'm going to go up another 1.5 to half. So if I graph that and call that the hare, if you notice, the hare's line is steeper than the tortoise's. And because it's steeper, that means we're going quicker up the miles than the time itself. So that means the hare is faster. But the tortoise rate of change is 2 over 1, and the hare's rate of change is 3 over 1. So which animal is faster? I would say the hare. And explain how you know. Because the rate of change is higher. All right, that concludes my proportionality quiz. Thank you for listening.